Hello, Algebra 2 AB. Today we're going to be talking about Chapter 12, Day 3, which talks about special right triangles, including 45, 45, 90-degree right triangles and 30, 60, 90-degree right triangles. Our focus is going to be to find side lengths of these special right triangles, and after that we'll have a homework assignment, which is Chapter 12, Day 3 worksheet. All right, so let's get started. First, we're going to talk about there we go. First, we're going to talk about 45, 45, 90-degree right triangle. So in a 45, 45, 90-degree right triangle, the hypotenuse is root 2 times as long as each leg. So we have two possible equations that we could use. One is talking about the hypotenuse and how to find it. To find the hypotenuse, you just take the leg and multiply by root 2. And we could also have an equation that talks about the leg. If we just rework this first equation to isolate the leg, we divide by root 2 on both sides, and that gives us that the leg equals the hypotenuse divided by root 2. All right, so if we're starting with the leg, then what we would do to find the hypotenuse is just multiply that leg by root 2. If we're starting with the hypotenuse, to find the leg, we just divide by root 2. Okay. One thing that you can think about when finding these lengths is the hypotenuse is going to be bigger, so to find the leg, we're going to divide to get that smaller length. And then if we're starting with the leg, we're going to multiply by root 2 to get the hypotenuse. All right, so it all depends on what side you start with. Now, how you know what side you start with is you could use these ratios. Obviously, we could look at a picture, and the side that's opposite that 90-degree angle is the hypotenuse. The other sides that are opposite those 45-degree angles are the legs. All right, so you'll see these ratios, and that means, so we have 1, 1, root 2, which means the side opposite that 45-degree angle has a ratio of 1. The other side opposite the 45-degree angle also has a ratio of 1, which just means that they're the same. And then the side opposite the 90-degree angle has a ratio of root 2, so we just multiply the leg by root 2. Now we find these using Pythagorean theorem. What we're basically doing to get this theorem is we're taking a square, all right, where the side lengths are 1, and we're just dividing that square in half. Okay, if we divide that square in half, splitting that 90-degree angle in half gives us 45. Same thing over here, so there's our 45, 45, 90-degree right triangle. And if we just call the hypotenuse x, we could use Pythagorean theorem to find that hypotenuse. Now, supposing that we have a square with side lengths of 1, we have x squared equals 1 squared plus 1 squared. 1 squared is 1, so we have 1 plus 1, which is 2. And to solve for x, we'd take the square root. So that's where we get that ratio of root 2. Okay, and that's how this works. If these lengths were 2, then this would just be 2 root 2. Okay, so now let's use this. Okay, got to clear the board first. So in example 1, we have a leg of 8 units, and we know that's the leg because it's opposite that 45-degree angle. So just using our ratios here for a 45, 45, 90-degree right triangle, which is 1, 1, root 2, the other leg is also going to be 8. And then to find the hypotenuse, we just multiply that leg by root 2, so we get 8 root 2. Pretty simple. One good thing about these special right triangle ratios is, we can use Pythagorean theorem to find these lengths, and that's how we get these ratios to work every single time. All right, so if we move on to the next example, I'm going to clear the board. Okay, there we go. In example 2, we're starting out with the hypotenuse. So when we start out with the hypotenuse, to get back to the leg, we're just going to divide by root 2. So I'm just going to write down 6 divided by root 2. And now we've got to get this radical out of the denominator for it to be a simplified radical expression. So to get that radical out of the denominator, we're going to multiply it in the numerator and denominator by the square root of 2. Now if we multiply just straight across here, we have 6 root 2 in the numerator, and then square root of 2 times the square root of 2 is just 2. And now we can simplify this part of the fraction here. 6 divided by 2 is 3, so that's just 3 root 2. All right, so that means both of the legs are 3 root 2 units in length. Awesome, so that's basically our 45, 45, 90 degree right triangles. If we start with the leg, multiply by root 2 to get the hypotenuse. If we start with the hypotenuse, multiply by root 2 to get the leg. All right, let me clear this board and let's move on. All right, now let's just go over, some more simplifying radical expressions across from that 45-degree angle. We have one of the legs. Across from the other 45-degree angle, we have another leg. And remember, this is just splitting a square in half, so we know that these two parts of this triangle are congruent. Those are the side lengths of that square. All right, where this would also be 4 root 3 units in length. I keep saying 4 root 3, and I mean 4 times the square root of 3. Now to get the hypotenuse, we just multiply that leg by the square root of 2. And if we multiply these together, we get 4 times the square root of 6. And this is already simplified. Root 6 has no perfect square factors that we could take out. So this is simplified. So x equals 4 times the square root of 6. All right, and moving on here. Oops, there we go. Now we have 7 root 2 over 2 as the leg of this 45, 45, 90 degree right triangle. So that makes this leg 7 times the square root of 2 on 2. And now we just multiply that leg by root 2 to get the hypotenuse. And I'm going to just write this up here, just in case we need some space to do some simplifying. We don't need that much, but we're going to multiply that leg by root 2. And when we do that, root 2 times root 2 is just 2. So that's just 7 times 2 divided by 2. I'm just writing it like that because then we can see that 2 divided by 2, those are going to cancel out because 2 divided by 2 is 1. And we just get 7 as the hypotenuse. All right, awesome sauce. Clearing the board. Let's move on. All right, now we're talking about a 30, 60, 90 degree right triangle. In a 30, 60, 90 degree right triangle, the hypotenuse is twice as long as the shorter leg. The longer leg is root 3 times as long as the shorter leg. All right, so the hypotenuse we could find just by multiplying the short leg by 2, and then the long leg we could find by multiplying the short leg by root 3. Now let's just really quickly talk about how we get these ratios again, like we did in the last example. All right, so what we're dealing with here is instead of a square, we're starting with an equilateral triangle. All right, so in an equilateral triangle, remember all 3 sides are congruent for the same length, and each one of these angles, if it's an equilateral triangle, it's also equiangular, so each one of these angles would be 60 degrees. Now we're splitting this in half right here from top to bottom. Now when we do that, we're creating a right angle here, and then we're also splitting this angle in half, so that angle would be 30 degrees. So that's how we get this 30, 60, 90 degree right triangle. Now let's suppose that in that original equilateral triangle, we had side lengths of 2. Okay? Now if we see what happens here, since this bottom side was 2, we just split that in half, so that makes this 1. And now what we're looking for really is the height of this triangle. So we could use Pythagorean Theorem to find the height of that triangle. And if we write down Pythagorean Theorem, we've got 2 squared equals h squared plus 1 squared. And now let's just solve for h. So we get 4 equals h squared plus 1. Oops. Got to use that. There we go. And I'm going to just move this up. I cannot do that. Okay. Now we're going to subtract 1. So we get h squared equals 3. And then when we take the square root, we get root 3. So that's how we get these ratios. You'll see 1, root 3, and 2 as the ratios for that 30, 60, 90 degree right triangle. So what those ratios are saying is across from that 30-degree angle, we have the short leg, which has that ratio of 1. And I'm just going to label that SL. And then across from the 60-degree angle, that is the longer leg. It's the longer side, and I'm just going to label that LL. And then obviously the longest side is always the hypotenuse, but we're going to label as the hypotenuse across from that 90-degree angle. And that has a ratio of 2. So if we start with the short leg, then this is going to be really easy. To get the long leg, we just multiply by root 3. To get the hypotenuse, we just multiply by 2. But when we start with either one of these, it's a little bit more difficult. Still not too bad, but a little bit more difficult. What we want to do is, if we start with the hypotenuse, we want to get back to the leg, the short leg, because everything's easiest when we start with that short leg. So we would divide by 2 to get back to that short leg, and then multiply by root 3 to get back to the long leg. All right, if we started with the long leg, we would get back to the short leg by dividing by root 3, and then we'd multiply by 2 to get the hypotenuse. So it all depends on what we start with. If we start with the short leg, like in this next example, it's going to be the easiest. So in this example, we're starting with the short leg, and we know that because this 30-degree angle is right here, and opposite that 30-degree angle is going to be the short leg. Okay, opposite the smallest angle in the triangle is going to be the shortest side. Okay, opposite the largest angle in the triangle is going to be the longest side, which is the hypotenuse. And obviously that long leg is just in the middle. All right, so we're starting with the short leg. To get that long leg, we just multiply by root 3, so we get 3 root 3. To get the hypotenuse, we would multiply by 2, so 3 times 2 is 6. And remember, when I say we're multiplying by this, we're always multiplying that short leg by those ratios to get the long leg and the hypotenuse. So that was a relatively easy example. Now let's just like ramp it up a notch, right, by starting with different legs, and then also by, doing some simplifying radicals. So now we're starting with root 3. So we've got a radical, and now we're going to find the long leg. So we'd multiply this by root 3 to get the long leg. Now root 3 times root 3 is not too bad. That's just 3. And then to get the hypotenuse, we'd multiply it by 2. All right, so 2 times the square root of 3 would be the hypotenuse. All right, once again, not too bad. All right, let's move on here. All right, now we're starting with the hypotenuse. These are not the most difficult examples, okay, but they're a little bit more difficult than starting with the short leg. When we start with the hypotenuse, we got to get back to that short leg. That should be our first objective. All right, so to get back to that short leg, we divide by 2. Once again, those ratios are of that 30, 60, 90 degree right triangle is 1, root 3, and 2. So we're starting here. We're trying to get back to the short leg. That's why we're dividing by 2. So we get the short leg of 7, and then we're going to multiply by root 3 to get the long leg, because we're using the short leg here. So the long leg then is 7 root 3. All right, not too complicated so far. All right, let's keep on moving. All right, and in the next example, we're starting with the long leg. This is where we're going to see our most difficult types of examples. All right, so starting with the long leg, that corresponds to a ratio of root 3. Okay, because there's the long leg. So to get back to the short leg, we're going to divide by root 3. So now I'm going to do this off on the side here. 9 divided by root 3. We got to rationalize this denominator. So we got to multiply by the square root of 3 over the square root of 3. Then we have 9 times the square root of 3 all on 3. And then we can simplify that fraction there. 9 divided by 3 is just 3. So that's 3 times the square root of 3. So that required a little bit of work for us to find the short leg. And then now from here it's pretty easy. We just multiply by 2 to get that hypotenuse. So we got 6 times the square root of 3. All right, let me clear the board. All right, last example here. We have the long leg that we're starting with. We know that this is the long leg because opposite that 30-degree angle is the short leg. Right? Opposite the 60-degree angle is the long leg. Opposite the 90-degree angle is the hypotenuse. All right, so we're dividing by root 3 to get the short leg. 6 times the square root of 3 divided by the square root of 3, that's just 6. And then once we have the short leg, let's multiply by 2 to get the hypotenuse, which would be 12. All right, folks, that's it. If you have any questions, send me an email. And as always, have a good day. Thank you.